Okay, so I'm going to try to keep this to be a short video, hopefully less than 15 minutes. And what I'd like to do is you can use your same kind of week 3 GIS data folder. And if you didn't know where to find that, it's on Moodle. So if you go to Moodle, you'll see under week 3, if you click the assignment, there's the zipped file right there. So you can grab it there if you need to. So go ahead and open up the QGIS file. Okay, and we're going to just look at that same piece of data that's in the quiz, which is the Baltimore, and I believe it's called census blocks. So it's just that one file that we're going to look at. So just a quick reminder that what we're looking at here are geographies, or these are kind of the shape of the actual shapefile polygon. And this is a layer, so the layer is pointing to the actual shapefile, which is in a folder in kind of the O1 data folder. So the data is stored in the browser, and a representation of that data, which is this layer, is being shown here right now as a green symbol with a black border. And these geographies all relate to specific records in an attribute table. And so the attribute table is just like Excel. Every single record goes down the edge like this, and then each of those records has different attributes, which are the fields going across the top. And so right now we're showing a single symbol for every single record. So we just see the same green with a black border for every record. But we have data associated with those records. So each of these geographies has a different population. So what I'd like to do is show you how to paint the data so that we can kind of see this, paint the geographies different colors so that we can see the data more clearly. And so that's kind of the point of this video. The first thing I'd like to do is we're going to actually create a new field. So we have these existing fields here, but I want to create a new one, which will be percent African American, right? And so what we need to do that is we need to take this field, black, and divide it by the total population to get the decimal, and then multiply by 100 to get the percentage. And so to do that, what we're going to do is we have to we can go right here. It says Open Field Calculator. And so the first thing to do is to right-click the layer, go to Open Attribute Table, and then once you have your attribute table open, you can go to this kind of abacus-looking thing here and say Open Field Calculator. And so for better or worse, GIS programs are full of these kind of what are called windows or GUIs, graphic user interfaces. So they're just these, you're going to have to learn about all these different windows, one step at a time. So this one is the field calculator, and what it does is it's going to allow us to manipulate our table. And so we want to create a new field, so that's fine. I'm going to call the new field PERC %, and then I'm going to just use a hyphen and then AA for African American. Now the output field type, because it's going to be a decimal, or I want it to have a decimal, I don't want integer, right? Because integers are whole numbers. So I want to go down and pick real, decimal number real. And then I tend to like these to be pretty long, because why not? Let's make sure we have as much information as possible. So I'm going to change the output field length to 20. And precision has to do with how many places after the decimal we're going to get. So the precision I usually put as 2. We want 2 decimal places. Now, we don't really need the output length of the field to be 20 if we're going to deal with a percentage, which means at most we would have 100%, which is only 5 digits long, right? 100.00%. So really we could get away with this being 6 or 7 or 5 or whatever it is. But I just do this by habit. If it's going to be real, I usually put it at 20. Okay, so the next thing to do is go over to this window here, and what we're going to do is pick our fields and values. So that's this caret right there. I open that caret, and what I want to do is I want to take black, and now it's saying, okay, yes, the field called black, and we're going to divide it by the field called total pop. That's total population, and so that'll get us from anything from 0 to 1, right? But we want to multiply it by 100 so that it appears as if it's a percentage. So I'm going to say times 100. And that's all I have to do. I can do that, and when I hit OK, it's going to create a new field. You'll see what I mean. Okay. And now it's created a new field over here. And we have percentage. And it looks like there's some null values, and those are places where there is no reported information. So that's okay. So we feel pretty good about that, actually. So now I'm done. What I need to do is I need to hit Save Edits. And what the tool has done is it's automatically put us in what's called editing mode. So whenever we actually change the source data to a file, we usually need to be in editing mode. And when I hit Field Calculator, it just did that automatically. Okay, so I'm going to toggle the editing off because we're done editing. I'm going to close my attribute table. And now what I want to do is I'm going to go back into my layer here, and now I want to paint these different colors based on the percentages. Excuse me. So to do that, I need to go to Properties, and this is kind of our home base when it comes to cartography. This is where we change all the symbology and do a bunch of different stuff. So we go to Properties, and then make sure you've got the Symbology tab open, and then we'll go from there. Okay, so hopefully from previous videos, this word symbology is no longer scary. It just means how we symbolize things and what we make it look like. So the single symbol is the default in Q. Like I've said before, everything gets the same value, the same color value, the same stroke, and all that kind of stuff. But what we want to do is we're going to end up making what's called a graduated color scheme. And so graduated is in general numerical, and categorized is kind of nominal, or it deals with names. So for instance, you might do a categorized color scheme with states, U.S. states, right? Because there's no number, but they're different entities. So this is a nominal thing, and this is a quantitative type of information. So we'll use graduated. And so for the value I want to use, I'm going to go down here and pick % African American, like this. And now what I've got here is it's letting me choose a color ramp. And what I want to do is I'm going to pick a different color ramp. I'm going to choose this Viridis one because I think it shows the breadth of the data a little better. So I'm going to choose that as my default color ramp. And then I think by default it has it on equal count, which is the same thing as Quantile. And so I could just hit classify, and it's going to give me a 5-class thing. So I'm just going to try that and hit classify, see what happens, and I'm going to hit apply, and we're going to see the data change here. So there we go. The data has changed, and now we're seeing how it's being represented. Now I'll try to mimic what we have in the quiz so that you can kind of see and get a sense. I'm going to put these in 2 different windows so you can see both at the same time. So we'll do that, and then we'll do that, so that should be clearer. Now the whole point of this video is to talk about the difference between these classification schemes. So the default was for Quantile, but there are these other choices we can make about how we're going to classify the data. And depending on how we choose to classify it, it's going to either diminish or enhance different parts of the data set, right? So the first thing to talk about is this histogram. So what we're doing when we're classifying is we're putting all of our records, or the geographies which relate to the records, into different bins, kind of different statistical bins, so that we can paint them all the same color. And so the easiest way, I think, to visualize and help us think about how we're doing the classification is to look at a histogram. And a histogram is not as complicated as it might seem. It's just a bar chart, but it's a bar chart that shows us kind of frequency and kind of counts the individual numbers of records. So it shows us frequency of values in our data set. The default is 30 bins. I'm going to hit 99s because I think it's a little easier to see the spread of the data. 99 means that it's going to count records in for every percentage point. So there's 99 breaks in the classes, so that 10 lines up with 10 and that kind of thing. So anyway, what we see here on the x-axis is this is our percentage points, right? So if we have a block over here, a geography and record, if we have a block that falls within 0 to 1 percentage point, it's going right into this. And this is a count over here of the number of records that are in that specific bin. And so it goes up and up and up, right? And so changing these bins just changes, you could do it in 5 bins, but that doesn't look very good, right? So this is showing us the same exact data set, but now it's just kind of lumping them into 5 different categories across. And so I'm choosing 99 because a percentage point, I think, makes sense in my head, at least, as how many different percentage points each one of these falls into. You could do half a percentage point or other types of things like that, but in general, I try to make my histogram bins relate to kind of the measurement, which in this case is percent. So anyway, 1 bin for each percentage point, and now we get to see how many records fall in each of those bins. So what does Quantile do? Quantile says, well, we ought to have the exact same number of records in each bin so that we can kind of see the spread, right? And so that it's a pretty good classification scheme to use at first, just to see the data itself. The problem with it is that in this case, what we have is we have kind of this crazy bimodal spread, right? Because of the segregated nature of how our society, inhabits the landscape. So we've got over here places where there is just 0. There are no African American people. And then there's places where it's above, really, there's above 98% are all African American in certain particular blocks. So because of that, the Quantile puts, there's the same number of records in each of these bins, but it's kind of spreading all the way from 10% to 90% using Quantile, so that between 10% and 90%, all of those records over here are being painted only 2 colors. So we can't really differentiate between, let's say, one of these records that has 10% African American versus 50%, right? So any one of these kind of light blue records or geographies could be any one of these things. So what we're doing is we're kind of overgeneralizing a pretty large swath of our measurement of percentage. And so to me, that's kind of not doing a great job of showing us some of the nuances in the data set. So how could we see that if we wanted to categorize this so that maybe we see actually a nice spread? One way to do that is to use the classification scheme called equal interval, which is the second one down here. An equal interval often, I think, seems like the most sensible to people because it's kind of the easiest to wrap your brain around. So instead of trying to put the same number of records in each bin, now we're kind of asserting that, no, we want the distance between the bins to be equal. And so the actual interval is equal rather than the number of records in each, right? So now if I do that and I hit apply, watch over here what's going to happen. I'm going to hit apply, and it greatly changes the way this looks, right? So equal interval has picked out some of the nuance in the middle of the data here. So now there are some records that we can distinguish between 20 and 40, 40 and 60, 60 and 80%. But now everything between 80% and 100% is all being painted one color, right? So this is a 5-class equal interval classification scheme. So in this case, this kind of in my mind, it overemphasizes places where there's a little bit more diversity, right? So we would say if something is 80% or 80.1% and something is 99.9% or 100%, those are being colored exactly the same way. So, this isn't perfect and the Quantile isn't perfect. So where does that leave us? What should we do? Another thing we could try is we could try these kind of natural breaks, which is called the Jenks algorithm. And natural breaks is just an algorithm that looks for similarity and dissimilarity between groups of records depending on how the spread happens, right? So if there was a big gap somewhere, it would pick out that gap and say, put one there, In this case, I'm not exactly sure how the algorithm is picking all of these different things, but you can read up about it online. when there are obvious gaps, it does a good job at picking those gaps. So if I do that and I hit apply, we get a little bit more of this kind of the outliers being more particular. And so it does a little bit better than equal interval, but it's still not perfect. Like if it was up to me, what I would want to do is I would want to choose to isolate these outliers, which are part of kind of the story here in the map, is that, wow, there's some records that, there's some places that are under 1% African American, and then there's some records that are over 99% African American, and these represent a large proportion of the total data set, and so that's kind of an interesting thing that we might want to focus on. And so, if you're not satisfied with some of these defaults here, which I would suggest at first only try and quantile, equal interval, and natural breaks, you can actually create your own classification scheme. So I'm going to create 7 classes because I want to highlight those outliers. In my 7 classes, I'm going to choose 0 to 5%. I'm just double clicking here because I want to check out what's going on. And I'm going to do 5%, I think, to 20, 20 to 40, 40 to 60, 60 to 80, and then I'm going to do 80 to 95. So what I've done now is I've said, show me these outliers, right? So now if I say apply, and now I go to my histogram here, I should see, yep, so I want a diversity of color to be shown here in the kind of body of the data, but also where the majority of the records are at each extreme of the data set. I want those to kind of be a narrower class so that it shows me that, yes, over 95% and under 5%, we consider to be pretty, in this particular case of kind of demographics, a pretty significant thing to look at. And so now when I look at this, I can kind of see, I think, the nuances of the data set a little bit more. So that might kind of lead you to ask, like, well, why don't you just have, infinite classes, and that is something we could do. We could just say, let's have 20, let's have 100 classes, right? So that would mean a different color for every single. Let's go to our histogram now. So now I've created a class for kind of every single one of those individual percentage points. And just because we can do this doesn't mean it's useful. And if you can imagine trying to look at a map that does this, and you wanted to pick out what one of these was, so you could say with certainty what it was, it would be pretty hard, right? To pick out the difference between some of these shades of green or shades of yellow or shades of purple. So it is useful to have fewer classes, because then somebody looking at the map can immediately look at it and kind of get a statistic. So if we have, usually they suggest between 5 and 7 classes, and usually no more. But if we stick between 5 and 7, then most people have no problem being like, okay, purple, and then they know that record is between 0 and 20, and the same for all the other colors. So I hope this was useful. Feel free to ask me some questions at office hours, or watch the video again if it doesn't make sense. The most important things we'd like you to know are equal count, which is also called quantile, equal interval, and then to just kind of know what a histogram is. And then this natural breaks is useful, but we're not going to expect you to know anything about how the algorithm works, just that it is an automated way of choosing, right? And sometimes we use the Jenks method to have it help us pick the classes, but then we round it off, because on our map we don't really want to have these decimal points. I think to the average layperson, it's easier to just be like, okay, 0 to 15% instead of 14.58, and ultimately it's not that big of a difference. So Jenks sometimes helps us find good breaking points, but I almost always do some form of manual classification after the fact. So that's all for this week. Good luck. I know it's a little confusing, but as we go on, we're going to actually start making maps. So it's pretty important to at least be exposed to this material. So, all right, thank you very much. See you in class or at office hours.